All right, so let's talk about what a scale factor is and then how we can solve some of the problems using the scale factor. A scale factor is the ratio that's multiplied by the original shape to make a similar shape. So real quick, similar shape means that it has the same ratios of the original shape. So if you have any angles, your angles stay the same. If you have any side lengths, the side lengths are going to be proportional to the next shape than your old shape. So let's take a look at how we should find it. How we find scale factor is we can use this equation to see what is the scale factor between the original shape and the second shape. So scale factor will always equal your new shape divided by your original shape. So let's take a look at some examples to understand how to use this equation and how it will always work. So in example 1, we can see pretty easy that 6 times 18 and 6 times 18 should be the same thing because we're looking at a square. So if you have easy numbers like this, you can tell that, well, I know that 6 times 3 is going to be 18, and I know 6 times 3 is 18, so my scale factor would be 3 because I would multiply 3 times my original square to get my new square. But let's look at that equation just so that we kind of have an idea of what it's really like to use it. Our equation says scale factor equals new shape divided by our original shape. So you get to pick whichever side that you want as long as they're corresponding. So in this case it doesn't matter because we're on a square. So I'll use my new shape side as 18. And my old shape or my original shape, which was 6. So whenever I simplify 18 over 6, then I'll get 3 as my scale factor. And so that's the same one that I saw earlier, so it worked out well. Let's take a look at the next problem. Let's take a look at example 2. Here I'm going from a larger shape to a smaller shape. And whenever we go from a larger shape to a smaller shape, typically you would think, oh, I need to divide by some number. But because our scale factors, whenever we're multiplying by, instead, just like you can divide by some number, it's also you could multiply by some fraction. So whenever you multiply by a fraction, usually you're going to have something larger in the denominator, and that would make it smaller. It's easy to find some things whenever you can tell that, oh, I know 24 divided by 6 gives me 4, and 6 divided by 6 gives me 1. So I know I would divide by 6. Or that's the same thing as multiplying by 1/6. So let's take a look at using our equation again just to double check to make sure we did it right. To find our scale factor, we need to take a side from our new shape and divide it by a side from our original shape. So just so that we're not dealing with easy numbers like 1, let's start with 4 as our new side. And the corresponding side to 4 is going to be 24. We know we must always reduce our fractions to its simplest form. So I know that 4 can go into both 4 and 24. So that leaves me with 1/6 as my fraction, and that is my scale factor, which is the same thing as saying that, oh, I've divided by 6. Let's take a look at one more example. Here in example 3, you can tell that our numbers aren't as easily figured out because there's, I don't know off the top of my head, something that goes straight from 16 to 40 or from 5 to 12.5. So we're going to have to use our equation this time to know what is the scale factor. Your scale factor is always going to be your new shape divided by something from your old shape. The biggest thing is that you will have to make sure that you're using corresponding sides. So in this case, we can use either one. We can use 16 and 40. We'll do it once with it, and then we'll do the other side just to double check. My new side length was 40, so I'll put it on top, and my original side length was 16. We know that we can't leave a fraction unsimplified, so I know that 4 can go into both of these, and I go down to 10 over 4, which then reduces back to 5 over 2. So 5 over 2 is my scale factor. I would multiply 16 times 5 over 2 to get me to 40. Let's double check and make sure we can do the same thing for 5 and 12 and a half. And if it is, then that means we know our scale factor. My other side length, other than 16 and 40, is going to be 5 and 12 and a half. For my new side, it's 12.5. For my original side, it's 5. It's going to be hard to make sure that we're on the right track. So instead, it would be best if we can turn this into an improper fraction so that we can solve to make sure. Or if you have a scientific calculator, then you can type it in and then change it from decimals to fractions. 12 and a half will go to 12 and 1/2. Whenever I turn that into an improper fraction, it becomes 12 times 2 is 24, plus 1 is 25 over 2, divided by 5. We've practiced how to divide a fraction by a whole number, so instead I'm going to rewrite it underneath and say 25 over 2 divided by 5. And whenever I divide by a whole number, I need to make it into a fraction first, so I'm going to put a 1 underneath it. And then if I know that I'm dividing by a fraction, I need to keep flip change, so I'm going to keep my first fraction, 25 over 2, flip my second fraction, make it 1 over 5, and multiply. I'm going to change that divide to a multiply sign. So whenever I simplify this, 25 times 1 is 25. 2 times 5 is 10. And this reduces to, 5 can go into both of those, 5 over 2, which is the same thing as what I found for my scale factor earlier using my other two side lengths. So in this case, sometimes you may have to work a little harder to find your scale factor, but if you use the equation, then it's still going to work. I hope this video helps.